This next example in 1.4 day 1 is a bit of a different way to put functions together. This one, instead of calling it combinations, we're calling it compositions. And what compositions mean are when we insert one function into another one. First of all, just a little bit about the notation. You've maybe seen this before, f of g of x and g of f of x. There's going to be an alternate notation for it. Sometimes we call this fog of x or goff of x. But these mean, this little dot doesn't mean multiplication, it means a composition like this. So what I do when I start a problem like this is I just change this notation into this one, because then it's pretty obvious that there's something on the inside rather than just being multiplied. And so let's take a look at these different ones that we have here. So let's start with f of g of x. Now what I like to do is just identify what is it that's going on the inside here, and then think about the outside. We have f of something. Now normally there's an x in there if we're doing f of x, but what I'm going to do is take this function and call that the skeleton. That's my framework for this problem, and I'm just going to leave blank that spot that had an x in it, or any spot that had an x in it. And so I'm going to do empty space squared minus 1, and that just represents x squared minus 1 from f of x. Now inside here I'm filling that in with g of x, which in this case is 2x minus 3. And so now this is my new function. If it asks us to simplify, then you'd probably have to FOIL this out and everything. But I'm okay if we just leave it like this for now. This actually is a little bit more clear about what we're trying to do. Number 2 is similar, but just the other way around. Now for number 2, we're doing g of f of x. So g is the framework, or the outside, the skeleton of this problem. And so we do empty spaces wherever there's an x for g of x. So we've got here 2x minus 3 from this one. Now we fill that in with f of x because it's just going the opposite direction. And we have this one. That'll be a little easier to simplify than the first because we could just distribute the 2 and combine like terms. But that's where we would be at for g of f of x. Now this last one you'll notice is f of g of 4. We've actually already found f of g of x. It's right up here. So really that's just taking a specific value of f of g of x. So I could just borrow it from up here and say, well, then that's 2 times 4 minus 3 squared minus 1. And then I could evaluate that from there. So it looks like we would have 8 minus 3, so 5 squared. So we'd have 5 squared minus 1, which is 25, minus 1, which would give us overall 24. And so anytime you see an actual value plugged in for x, you should expect to get a number answer out in the other end.